Some nuclei are not stable. If they are not stable, they will convert to a more stable state by either releasing particles or other forms of radiation. These changes are called nuclear reactions.
Nuclear reactions are often called transmutations. What happens in a nuclear reaction is that you have a beginning nucleus that undergoes a change, and then it becomes a new nucleus, and some kind of radioactivity is emitted. That new nucleus is often a new element, and so we call it transmutation of the elements. This process of going from an original nucleus to a new nucleus is called radioactive decay, because you actually start losing the amount of your original element as it is transmutated to a new element. And so the amount of the original sample decays in concentration. When we're looking at a nuclear reaction, what we do is we find that we can write the reaction by balancing the mass and the charge. Now, here it says the sum of the mass numbers must be the same on either side, and the sum of the atomic numbers is the same on either side. It's much easier just to say that the mass from the beginning to the end cannot change, nor the charge from the beginning to the end cannot change. So what we do is we look at all the mass of all the particles on one side and the mass of the particles on the other side and make sure they match. And we look at the charge on the reactant side and the charge on the product side and make sure they match. And then the nuclear reaction is balanced. Here is an example of a nuclear reaction. This one's called alpha emission because an alpha particle is emitted from the nucleus. The nucleus before the reaction occurs is uranium-238. Now, uranium-238 has a mass of 238, and the charge on the nucleus is 92. When it decays, one nucleus will emit an alpha particle, and then that one nucleus becomes a thorium-234 nucleus. This, if you look at the mass on the reactant side, it's 238. If you look at the mass on the product side, you can see that 4 plus 234 is also 238. If you look at the charge on the reactant side, you'll see it's 92. And if you sum up the charge on the product side, you'll see it's also 92. This is a balanced nuclear reaction. The reason it's called alpha emission is you can see that the alpha particle is spit out by the uranium nucleus. After it spits out that uranium nucleus, after it spits out the helium nucleus, then it becomes thorium. Let's look here at an example of how you can write a nuclear reaction. The statement says, write a balanced nuclear equation showing how americium-241 decays to form an alpha particle. The way that you're going to do is you're going to start by writing americium-241 as the reagent or as a reactant. Be sure to look on the periodic table to see what the atomic number of americium is so that you can put the charge down as 95. Then you know that it's going to be emitting an alpha particle. So you put an arrow and then you put an alpha particle, which has a mass of 4 and a charge of 2. Now you have to figure out what is produced by this. The way you do this is by mass and charge balancing. So you look at 241 and you see that it's going to produce a mass of 4 plus a mass of something else. The sum of the mass on the product side has to be equal to the reagent side so that you know that the mass must be 237. the sum of the charge must be equal to 95, so you know that the new product must be 93. You go to the periodic table and you look at the element that is atomic number 93, and you see that it's neptunium. So then you can write neptunium as the element. Let's look at an example of beta emission. We can see that carbon-14 will undergo beta emission. Notice the symbol for beta emission is given there: 0, -1, 0 mass, and -1 charge. If you look at the sum of the masses, you can see that 14 is equal to 0 plus 14, and 6 is equal to -1 plus 7. Be careful with your addition of negative numbers. So carbon-14 will make nitrogen-14 plus emit a beta particle. Positron emission is the decay of a nucleus by emitting a positron. Notice that the charge on a positron is 0, the mass of the positron is 0, and the charge on a positron is +1. If you look at the sum of the masses, you can see that 11 is equal to 0 plus 11, and 6 is equal to +1 plus 5. This is a balanced reaction. Gamma emission is a little different from the others because gamma radiation has no mass and no charge. When you have a gamma ray emitted, there is no change in the charge, and there is no change in the mass, so the element does not change. What happens is that the nucleus is in a high energy state, and it decays to a lower energy state by emitting a gamma ray. Gamma rays, even though they are not particles, are the form of light to have the most energy, more energy than even an X-ray. And so when they collide with something, they have a tremendous amount of energy, and they can do a great deal of damage. Go ahead and try to figure out what particles are missing in these nuclear reactions, and identify what type of nuclear reaction is ongoing, what type of emission is occurring. After you stop and do these problems, go ahead and check your answers. Okay, to do this problem, the first thing you do is you have to put in your mass and charge on your alpha particle so that you know what you're doing. Then you look and you see 226 is the mass on the radium, so the new particle plus 4, new particle plus 4 must add up to 226. So the new particle has a mass of 222. The charge on radium is 88, so the mass of the new particle must be 2 plus 86. You look up 86 on the periodic table, and you can see that it is radon. To do the next problem, we look at the mass and we see we go from 3 to 3, so the mass of the remaining particle must be a 0. On the charge, it's 1 on the reagent side and 2 on the product side plus something else. You think to yourself, 2 plus what equals 1, and you will then say, well, 2 plus -1 is equal to 1. So this must be 0 for the mass, -1 for the charge. The only particle with those characteristics is the beta particle, so now we know a missing particle. If we look at their last reaction, we can see that the mass is not changing, nor is the charge. That means the particle has to have no mass and no charge. The only thing that has those is a gamma particle. Now, if we look at each of these, we can see these are all emission particles, emission reactions. The first one is alpha emission, the second one is beta emission, and the third one is gamma emission.